In this lesson, we're going to talk about power supplies. Now, the power supply plays a crucial role in your PC system. Its job is to provide electrical power to every single component in your computer system. What it does is convert 120 volt AC current from a wall outlet into DC current that can be used by the PC system. And it actually converts that 120 volt current into 3 different DC voltage levels. The 12 volt current is used by electric motors inside your PC system, such as your hard drive, such as your fan, etc. The 5 volt current is used by older motherboards. Newer motherboards use the 3.3 volt current. Here's a sample power supply. Now, these power supplies are mounted inside of your PC case. There's a hole in the back of your PC that exposes this particular face of the power supply. This is where you plug the power supply into your 110, 120 volt wall current. There's a power cord that plugs in here. The other end goes and plugs into the wall socket. Got a switch right here that allows you to turn the power from the wall off or on, turns the power supply itself off and on. And there's a switch over here that allows you to change whether you're using 115 volt or 230 volt current. The electrical current, the AC current, comes in through that socket, goes through the power supply, and is converted into DC current, which comes out on this end of the power supply. As you can see here, we have a whole mess of cables coming out of here. These plug into the various connectors or the various components inside the PC system. Now, it's important that you understand that not all power supplies are created equal. Just like you can go down to the hardware store and buy a 60-watt light bulb or a 75-watt light bulb or a 100-watt light bulb. Same with the power supply. They come in a variety of different wattages. If you have a lot of devices in the system, then you need to make sure that you have a power supply that supplies extra wattage. On the very low end, the most inexpensive power supplies will supply about 200 watts. In my experience, these are barely adequate for a very low-end system. I would avoid using a 200-watt power supply. For the typical end-user system, I would recommend about a 350-watt power supply. If you've got a server or a system that has lots and lots of drives and components in it, then you need more. You need something upwards of 450 up to even 500 watts. The nice thing is that price difference between the 200 watt and the 500 watt is not drastic. They do cost more, but it's not that significant. It's really worth the investment to go with the higher wattage. If you want, you can take a look at your system and look at the wattage used by the different components in the system, such as, we have the hard drive, we've got the motherboard, we've got a CD-ROM drive, and you can check and see the wattage required by each of these components and start adding it up. If the amount required exceeds the rating for your particular power supply, you need to upgrade the power supply. And this is important because this power supply actually has a second job. Its first job, obviously, is take 110, 120 volt AC current and convert it to DC current. But its other job is to ensure that there's enough power available to run the system. If there's not enough power available coming through the DC side, then the system will shut down. What happens is when the system is first turned on, the power supply runs a set of tests during the startup process, and if the power levels are sufficient, it sends a special signal on one of the wires going to the motherboard, coming through this plug right here. One of these wires is called the power_good wire. If there's signal on this wire, the system will start up. If there's no signal on this wire, the system will not start up. This applies not just to the boot up process, but while the PC is in use as well. If, for some reason, there's not enough power to supply the demands that's being asked of the power supply, the current will be lost on the power good wire. When that current is lost, the system will shut down. That's why you need to make sure that you use an appropriate power supply. If your components are demanding too much current from the power supply, the current will be lost on the power good wire, and the system will spontaneously shut down or reboot. Losing current on this power good wire can be caused by a couple of other things as well. Obviously, if you're plugged into the wall outlet and there's a problem with the AC side of the power, for instance, if you have a brownout or a blackout, obviously you'll lose power again on the power good wire and the system will go down. If the power supply is being overstressed because we have too many components on it drawing power from it, that will also cause the power to be lost on the power good wire and cause the system to shut off. It can also be caused, even though your power supply has plenty of wattage, if you've blocked air ducts and you don't have good ventilation around the system, this power supply can get too hot. When that happens, it gets overstressed, and the same thing can happen again. You lose power on the power good wire. Now, in addition to converting AC current into DC current and verifying that there's sufficient power to run the system through the power good wire, the power supply also has one other critical role, and that is its job is to cool the system. Inside the power supply, there's a fan, and we have this grating on the back here that actually is exposed in the PC case. The power supply fan draws air through the power supply and blows it out of the case. The idea is let's draw the hot air out of the case, and cool air would be drawn in through the cracks of the case to cool the system. Now, with the modern power supplies, the case is actually pressurized. And this is really good because it helps reduce the amount of dirt and dust that gets into the system. Now, in addition to the roles that we've talked about so far, the power supply has one other role, and that is to provide soft power to the system. In older AT-style power supplies and motherboards and cases, there was a hard switch, kind of like this one right here, and it was used to break the wall current, the 110, 120 volt current. That's how the system was turned off and on. Well, the ATX power supply is a little bit different. We do still have a switch back here, but that's not the switch that we use to turn the system on or off. The switch that we use to turn the system on or off is down on the front of the PC case. With an ATX power supply, there is a wire in this connector that goes to the motherboard that's called power_on. This wire allows the system to be shut down or turned on remotely. It can be shut down or turned on, for instance, by the operating system. If you've ever used a modern PC with an operating system such as Windows 2000 or Windows XP, you can say start, shut down, right? And what happens to the PC? It actually shuts all the way down. That's because current can be sent to the power_on wire to either turn the system on or shut it off. Likewise, you'll see a lot of keyboards on modern systems that have a key that says power. You can power the system on by pressing a key on the keyboard. Now, older systems didn't do that. In an older system, if you were in Windows and said start, shut down, the system would go all the way down, and then you'd have a message displayed on the screen saying it's now safe to turn off the PC, and you'd have to manually push the switch on the front, which broke the 110 volt power. With ATX power supplies, we have soft power through the power_on wire that allows us to be a little more flexible than that. Now, there's another wire in this motherboard connector that's called the 5V_standby wire, and it's always active. It provides a constant supply of 5 volt current to the motherboard, even if the system's shut all the way off. It allows the system to have a limited source of power at all times. As you can probably see, the power supply is really a critical component in your PC system. If it's faulty or malfunctioning, the whole thing doesn't work. No matter how fast a CPU or how much RAM you got, if you've got a bad power supply, might as well not have them. In this lesson, we talked about the role of the power supply in the PC system. We talked about the fact that the main job is to convert 120 or 110 volt AC power to 12 volt, 5 volt, and 3.3 volt DC power that the system can use. It's also responsible for ensuring that there's enough power to run the system through the power_good wire. It also is responsible for cooling the system. It has a fan built in that blows across the hottest components in the PC. It also provides soft power to the system motherboard through the power_on wire as well as the 5V_standby wire.